Welcome to this presentation on how to get the maximum performance out of SQLBase multi-user applications. I'm actually using SQLBase 11.7 and I'm going to show you in a quick overview what the main benefits of SQLBase 11.7 are. With SQLBase 11.7 you can choose between 32-bit and 64-bit database servers on Windows and on Linux. You get much improved security, including 256-bit AES database encryption and SSL over-the-wire encryption. And you get a lot more simplicity. There's a number of new database drivers that make configuring and using SQLBase version 11.7 very easy. But now let's talk about the theme of this presentation here. With SQLBase 11.7, you get new database drivers for the team developer development environment. These drivers support the new SQLBase RC1, RC2, and RC3 isolation levels that allow great multi-user performance. And these drivers do also support the new SQLBase 11.7 features like network authentication, for example. In the past, database locking with SQLBase was working like this. You did use isolations levels like cursor stability or release lock. And in those cases, X locks actually meant construction sites that totally block the road. So if anybody would update a row or a table or all rows of a table, everybody else would run into a road block. And this is how that looks. So let's see how that works. I have prepared a test environment that lets me show you quickly how the old method of locking did work. You can see there's a SQLBase 11.7 64-bit server actually running in the background here, and I have two SQL Talk programs open that allow me to simulate two different users actually. And let me execute that script here. In the first one, I do connect to one database with Connect Island, and you see that immediately there's a user displayed on the server screen. Then in that session, I set the isolation level to the historic release lock isolation level. And now I do update all rows of one table. Update companies at phone equals 110. And now actually this user, let's say, would go to lunch. And this other user here, connect to Island. And again, on the server screen, you should see the new connection. Here it comes. Also set the isolation level to the old release lock. Set the timeout value to 1 second. And then try to execute a select on that table. And as you see, after 1 second, it comes back with a lock timeout, transaction rolled back. So basically this update, open update, uncommitted update is blocking others that want to read that data. And that can happen quite frequently. For example, if you run large reports during operation times and users are working on the database. So every time the reporting cursor or the reporting database user runs into a lock, it might actually stop the transaction, or you need to wait for the transaction to finish or to finalize. So this is how the old SQL-based locking did work. And now if I do a rollback here, then I would be able to select on the other side. Now let's get back to the presentation. The modern system of locking is actually a virtual traffic bypass or a virtual road for database users. And the isolation level for that is called RC read committed. And that has three levels that allow you to fine tune how the RC modes are being executed. So it's a high-speed virtual detour for X locks, and so reading users will never run into any locks. And your traffic will continue to flow even if updates are being done. So how does that look? Let's go back to the database. My two sessions here, and let's again execute an update, and you will see the same behavior as before. The transaction is rolled back because it cannot come through because there are open logs in the database. Now let's open another SQL talk session, and let me open my predefined file here. That's easier for me, though I don't have to type everything. The RC script, which opens now. And this one, I do connect to the island database as well. But in this one, I set the isolation level to the RC mode, read committed mode, which has a totally different behavior. So just to remember you now, on this side here, we are still running into a log timeout when we try to read the data. And on this side here, we can read the data because history data is available in that isolation mode, and data readers can read data that is being logged by others. So this resolves the database contention problem for many users. So how does RC1 work? One is the most consistent read committed isolation level. The timestamp is not changed during a transaction. That actually means committed changes of other users or other sessions do not show up during the span of a transaction. So that's basically the safest or the most similar way to previous transaction behavior of SQLBase. There are two other modes. So let me demonstrate how the RC1 isolation level of SQLBase works. The timestamp will not be changed during a transaction, and so you should not see any changing data when new SQL statements are being executed during a transaction. So here's my little test application. What that does when I press the start button here is that in transaction 1, it will update the city of the company table and commit that update. In a transaction 2, it will actually, before the city is updated, read that data, and then I can still scroll through the data after it has been committed. And then I can also execute a new command in transaction 2, and then on that new command with a new cursor, I can also scroll the data, and all those will not reveal any changed data that has come through this update here. So let me start this. And you now see basically this time here is the timestamp of the transaction, and I can scroll through the data and it doesn't change. And I can scroll through a second result set, and here the data doesn't change either. So this is how RC1 works. All the data views during a transaction are totally consistent. Now let's see how RC2 works. With RC2, a timestamp is updated when a new command is executed. So committed changes of other user sessions show up after a new SQL prepare and execute is being run from the application program. So let me demonstrate the RC2 isolation level. This means the timestamp changes when a new command is executed. So let me go back to that presentation, and on the second tab here I have the start RC2 demo. Again, this reads the data, updates the city, commits the city, and those are both in different separate transactions. Let's execute this, and you see the timestamp here, and if I just execute SQL fetch next, basically, then the timestamp does not change. But if I execute a new command as part of the reading transaction here, then you see executing the new command actually retrieves the new data. There's a different timestamp here on this one, and scrolling through this data, you already see the updated data coming from this transaction here as during the course of a transaction. So that is what RC2 does. RC3, the timestamp is updated after calling any SQL function. So highest volatility of data actually. SQL fetch next retrieves changed data from other user sessions during a transaction. So as quickly as possible, you actually get to see what other users have done to the data. Now let me show you how the RC3 isolation level works. With RC3, the timestamp changes when any SQL function is executed. SQL fetch next shows the committed changes from other user sessions. So with this application, let me show you the RC3 isolation level. Again, I will press the start transaction button here, You see the query has been executed. You see the timestamp here as being 220 something, and the update and commit has been executed on a different transaction. And now with RT3, you get to see change data immediately if you press SQL fetch next, or if you execute SQL fetch next programmatically, and you see the change timestamp here. So basically, SQLBase isolation level RC3 lets you see committed changes from other users or from other sessions as soon as they have happened. With the next interaction with the database, those changes will show up in the application data. So now you can go ahead and unlock your multi-user application performance using SQLBase 11.7 and the new client drivers that allow you to leverage the RC1, RC2, or RC3 isolation levels. You don't need to change your applications actually to take advantage of those. You can have a SQL INI statement that actually automatically converts all RL release log isolation levels to the RC isolation level that you prefer. If you need more information on that, please visit our website, guptatechnologies.com, visit us on YouTube to view other videos on our products, or visit us on Facebook to get the latest on any company and product updates. Thank you very much for listening, and I look forward to talk to you soon.